All right, day 2.
Is it better than yesterday?
Is it better than yesterday? Are you better than yesterday?
A little more tired.
Am I better than yesterday? Is that the question? I don't know. Okay, so let's see. We ended up yesterday. We talked about fractions, and then we talked a little bit about word problems. I'll go back into word problems later today. But right now we're going to talk about decimals. And I'm happy to have my program back, or one that was like it. All right, we talk about decimals. We have to talk about place values of things. So we have our decimal. To the right of the decimal, what do we have?
Positive.
Well, tenths.
Hundreds. Thousands.
Tenths. It's kind of hard to write horizontal like this. Hundredths. What comes next?
Thousands.
Thousandths. Thousandths, and then 10,000ths. Okay, and to the left of the decimal, maybe we can do it this way. This is which place?
Ones.
Ones. This would be the. That works better. Tens. Hundreds. Thousands. Thousands. 10,000s. What comes after 10,000s? 100,000s. After 100,000s is millions. All right. I'm not going to write all that out for you. And I think we have probably learned that if we're going to add or subtract anything with a decimal, we have to always make sure we line up the decimal for doing it longhand. If you're using your calculator, of course you know you don't have to do that. Just use your little decimal thing. But I don't want to get into too much of that because I think you know that. And we talked about how to convert fractions to decimals. Remember how to do that? So if I want to do 7/8 and I want to make that into a decimal, how do I do that? What's that? Woohoo! Oops. If only it worked. All right. So we hit this, whatever. Yeah. Sorry, I don't have actually working ones up here, but just type in whatever fraction you have. So 7 ABC 8. Over here would be 7 ABC 8, which is going to give me a fraction. Hit the second function, and the F to D button, fraction to decimal. Wow, there we go. It's going to be over there today. Yeah, hello. There's your F to D button right there. All right. So to do that, it is just 7 ABC 8s, and then actually the second function key, F to D, F to D, F to D, and then we should get, what is my fraction? Hello? Did you not do it?
No.
0.875.
What's that?
0.875.
0.875 is correct. All right. If I have a fraction, let's just say I have 0.25, and you probably know this off the top of your head, but I want that fraction, I want that to be in a fraction, and I want it to be in 1/16 of an inch. How do I get 0.25 into 1/16 of an inch?
Times by 16.
There we go. We just multiply it times 16. So 0.25 times 16 is 4. You're going to get 4. You just have to remember that's 4/16. If I want it in 30 seconds, I would just do 0.25 times 32, and I would get 8, right? All right, and that's 8 30 seconds. So I think, was that one of the things I had you do in lab? Convert? Okay, so everybody's good on that now? One of the areas where I see many mistakes is rounding off. So rounding. Rounding off. All right. So if I have a number such as, well, rounding. All right, so if you came up with a number of 10.375 and I want you to round it to the nearest tenths, which number is that on here? Which position holds the tenths?
4.
4 is not up there.
To the right of the decimal, the first placeholder.
Is it the 1, the 0, the 3, the 7, or the 5?
3.
All right, so I have to round off to the 3. So the number is going to be 10 point something, right?
4.
All right, so why is it 4?
Because 7 is more than 5.
All right, so what we're going to do is we're going to take whatever it is we're trying to round, the space, and you can draw a line under it. You can look at the one to the right. If this number is equal to or less than what number?
5.
4. Haha, if it's less than, it's got to be 4. Equal to or less than 4 stays the same. If this number is equal to or greater than 5, round up. Round up. This really doesn't round down, it stays the same. Stay the same, even though we'd call it rounding down. So because that is a 7, 7 is more than 5, that becomes 10.4. What about the 5 out here? I mean, do I consider the 5 and then round the 7? And no, I don't. So all of this past there is just don't care. 10.375, and I say round to the nearest ones. So which number am I going to round?
0.
The 0. All right, I'm going to go up, down, stay the same.
Stays the same.
When do I go down?
You don't.
Hey, you don't. All right. What if I said round off the number pi? What is pi? 3.141. I know.
1417, I can't remember.
15.
1592654.
Yeah, right. We'll just make up some numbers.
That's what my calculator just said.
Oh, okay, you actually did it? Oh, wait, you're ready to go. Should have known. Should have trusted you. All right, and I want to round off to the nearest 10 thousandths. Which one is the 10 thousandths position?
4.
5.
5.
Tens, hundreds, thousands, 10 thousandths. So what would this number become then if I rounded that? 3.141 what? 6. All right. So here's going to be a problem. We're going to be working with stuff, and you're going to ask me, how many decimal places do you want? I say, well, I want 3 decimal places. All right, that's fantastic. So if I measured something, I said, well, it's 0.6259 amps, and I said I want it round in 3 decimal places, what's your answer going to be?
626.
0.626. Well, maybe. What is another way to write 0.6259 amps? 625.9 milliamps. No. See, the problem is if I say 3 decimal places, it doesn't work out that way. Because, well, wait a minute, 3 decimal places with an exponent, without. So that's why I never really threw out a rule. Well, you always got to be 3 decimal places. Because it doesn't work that way, because 3 decimal places up here is a whole different than 3 decimal places down here. So I say just round appropriately. And when possible, don't round. So if we're doing a math problem that entails a lot of work, especially when we get into AC, just keep whatever's in your calculator and move forward with the display. So you have 9 decimal places in most cases. But anyway, all right, so that's rounding. Let's see. Okay, so again, what position is this? Tens. This is And this is?
Thousands.
This is?
10,000.
Okay, tens, thousands. All right. There, I've resumed. All right, let's talk about ratios. I like ratios because now we're getting into something here that's going to be kind of cool. So there's a lot of ratio stuff on your FA tests, and the ratios are the key to all of the word problems. So where have we seen ratios before?
Pre-mixed gas.
Oh, what kind of two-stroke airplane you got?
It's my weed eater.
All right, what weed eater? What is the ratio? Okay, premix gas. We're gonna go with it because you called it.
50 to 1.
It's not really premix, but premix. I guess it is premix gas. What is it?
50 to 1.
50 to 1. Okay, so 50 to 1. So, right? So we've got 50 parts of gas to 1 part
Oil.
oil. Now, if you mess up and you go 50 parts of oil to 1 part gas, not going to run real well. Okay.
Always add more gas.
Smoke your neighbors.
Okay. That would get rid of our mosquito population, right? Okay. Okay. Something a little more airplane-y.
Compression ratio.
There we go. Compression ratio. It is now. Trying to spell here. Far enough to C-O-M-P-R-E-S-S-I-O-N. Compression ratio. What is a compression ratio? What is it?
It's from TDC to.
Come on. Last semester. You got it.
Yeah, it's from BDC to TDC.
All right. It's the difference between the volume. So the difference in volume. V-O-L-U. Oops, messed that up. U-N. Difference in volume of a cylinder between top dead center versus bottom dead center, which if you don't understand that, that's kind of okay because we're going to talk about that next semester. If you haven't had that yet, if you already had it yet and you don't know what that means, you have a problem. All right. So what? So it's the difference in volume of a cylinder when the piston's on the bottom. There's a whole bunch of the cylinder can hold a whole volume of a liquid or a gas, and versus when the piston's at the top. So it's the difference between the two. So that's the compression ratio. And what's a compression ratio about? 9 to 1, 12 to 1, somewhere between around 12 to 1, 15. So that would be normal. Okay, aspect ratio. In airplanes, what is an aspect ratio?
Wingspan.
There we go. If I had a wing that looked like that versus a wing that looked like this, but straight, swept back a little bit the tip. It's going this way. All right. So we have two different aspect ratios. This would be a low aspect. This would be a high aspect. It'd be the ratio of the width and the length. That's the width, that's the length. So a low or high aspect ratio. Talking about fuel, we have air and fuel. Air-fuel ratios. What is considered the chemically pure ratio of fuel to air? What's that word?
Stoichio.
Stoichio.
Metric.
Metric. Spell it.
M-E-T-R-I.
S-T-O-I-C-H.
If you didn't even have it written down, you probably couldn't spell it.
Sometimes I can spell it, sometimes I can't. I don't know. What is stoichiometric, Brett?
Whoa.
What is the ratio? since you're talking over here. Is it 50 to 1?
15.
Okay, is it 15 to 1? 15 to 1 is correct.
Oh, damn, put me on blast then.
15 parts what?
Air.
Air, thankfully, to 1 part
Fuel.
fuel. All right, so you can see we can talk a whole different kinds of ratios, and as you can see, I've talked about 15 to 1. It's usually to 1, although it's not wrong to say it's 1 to 15. It's weird and it's a little wrong. We don't say 1 to 15. I don't know why, whose rule it is, but it's 15 to 1. You put the big part in the front. So we can do a ratio like that. I prefer, just the way I think when I talk about fuel-air ratios, what's a lean mixture?
12 to 1.
Well, is it,
No.
No.
there's lean and there's rich.
Rich is too much fuel.
Too much fuel, so I'm losing what?
Air.
Air. So rich should be what, 8 to 1? And lean is 18 to 1. It'll still burn through that whole range, right? But I like this because I can see that. I can go, okay, 18 to 1, 15 to 1, 8 to 1. And if I said, oh, I'm running 12 to 1, am I a little rich or a little lean? I'm on this side, a little rich. A lot of books don't like to talk in 15 to 1 ratios. They're going to give me another number, and they'll just call their ratio, instead of 15 to 1, they're going to call it 0.067. Where in the heck did that just come from? Your calculator. How did that calculator spit that out? 1 divided by 15. So you can also express a ratio as a decimal. I guess if you get used to it, it might be okay. What is 8 to 1 as a decimal? 0.125. And what is lean as a decimal? Point zero 0.0555555556. I can just go 5.6. And how did you get that? You hit the 1 and then divided by, and then the, okay, there is a shortcut. There's a 1 over x button, which simply means that number divided by 1. So I can just hit 15 and hit the 1 over x. I call it 1 over x key, and I'm going to get that answer. We're going to use 1 over x a lot, just so you know. So anyway, that's another way to display a ratio. Just out of curiosity, who would prefer to see it like this in a decimal format versus in 18 to 1 or 15 to 1? You like the decimal better? Okay, I don't have a problem with that. I was just curious who likes to look at it in the older style, like the 15 to 1. All right, yeah, I'll keep that. And who absolutely doesn't care? Because you didn't understand to begin with. Too late, you already raised your hand. All right. Let's see. What if it's given to you in 0.067 and you really don't like that and you want to see it in something like 15 to 1? How am I going to get that answer? Just divide by 1 again. So I can do 0.067, hit that 1 over x key, and it's going to say 14.99 something or another, or around there, 1492, I guess. So it gets close. It gets close back. All right. Anyway, there's ratios. So you can see ratios in all kinds of different way. I'm going to skip that and go to, yeah.
Your ratios the same way that they put the big number first?
When I mumbled up here, I'm going to skip that.
Oh.
Gear ratios. I'm going to circle back around. Well, I don't know. You brought it up. What the heck? Okay, we also have gear ratios. All right, and so gear ratios. In all of your questions that you're going to see, they're always going to say, what, a spur gear. Spur gear. And what's the other one? The spur gear and pinion, yeah. Pinion. It doesn't matter. It's just both gears. Now and so it doesn't. You don't have to remember which one's a spur, which one's a pinion. You don't have to do anything. But you can just even call it gear A and gear B for all it matters, because you're going to get it right. So if you said gear A has 8 teeth and gear B had 28 teeth, it can't be a Rio Linda one with 1 tooth. Shouldn't say that. Sorry, I didn't mean that. So what is my ratio?
2 to 7. Or 7 to 2.
What is my ratio? Well, quite simply, what are my two numbers? 8 to 28 or 28 to 8. Same thing. I could reduce it down, couldn't I? Divide by 2. So what would I get? 14 to 4. Well, it looks like I could reduce it again, couldn't I?
7 to
1 7.
7 to 2. What if I want to get it down to 1?
No.
3.5 to 1. 5 to 1. So it's just a ratio. We're going to talk more about gear ratios. They're the exception to the rule for solving problems. They're the exception. But it's an easy exception. You just have to remember that you have to keep that in mind. So, all right. So let me see. Solving problems. I'll say word problems. They're very, very simple. Every word problem on the FAA test can be solved by creating a simple proportion. And you just have to set it up right, and it's not really that difficult. I'll write this. So every FAA word question, can be solved by creating a proportion. Everyone. So if you look at it, three quantities are always given. And you need to find the fourth. They're all that way. Example. An airplane flying a distance of 300 miles. So an airplane. I don't want to write all that out, but I am, I guess. An airplane flying 300 miles used 24 gallons of fuel. How many gallons to fly 750 miles? All right, so we're just going to set it up as a simple ratio problem. So you have a line equals a line. On one side, we have miles, gallons. I'm going to do the same thing over here. Miles, gallons. So what do we know? Over here, we can put the given. How many miles did I fly? 300. And how many gallons? 24. And I'm going to come over to here. This is like my answer side, but I still have more information. What do I have, miles or gallons? How many miles? 750. Gallons is my unknown. That's what I'm trying to find. That's my X. All right, so to solve this, you have to cross multiply. You have to multiply this times that and multiply this times that. So when I do that, 300, we'll do this. 300 times X is what? Okay, that's just 300x x, which is really the same thing as saying 300 times x. So I said, what's 300 times x? Well, the answer is 300 times x. That's I just write it as 300x. All right. And that equals, because here's my equals, and now I'm going to do this one. What is 24 times 750?
18,000.
70. I'm learning to not trust you. 24. 24 times 750. It's 18,000. Why did you say that?
I did.
Oh, okay. 18,000. Hey, now we have to solve this. So solve this. So I'm just going to move this over here a little bit. We have 300x equals 18,000. That's another way of saying 300 times some number equals 18,000. Now, intuitively, you might think, well, we can just do simple division, but hey, let's do it the long way here. So I need to get rid of this 300x. I want it to be just x. So how can I make it just x?
On both sides.
If I divide by 300, it will become 1. So 300. But if I do it to one side of the equation, I have to do it to the other side. Whatever you do to one side of the equals, you have to do to the other. So if I'm going to do it here, I got to do it over here. So that's 300. Now 300x divided by 300, the answer is 1x. But we don't usually write the 1. We just write x. So I can erase that. So we just say x, which is really the same as 1x. It's just x, okay? But over here, I've got 18,000 divided by 300. So 18,000 divided by 300 equals 60. So what I'm saying is 60 what? 60 gallons. So I'm saying that if I want to go 750 miles based upon that formula, it's going to take 60 gallons. Can I figure out if I'm right with this?
Yes.
Okay. So we can double check, because if x is 60, all I got to do is bring it back up right there and go, oh, we'll make that 60. So what's 300 times 60? 300 times 60 equals, oh, look at that, 18,000. So does 18,000 equal 18,000?
Yes.
It's supposed to. Every single FAA problem is like that.
Is it always multiplication or is it sometimes division?
It's the I did all. I did multiplication and division. What do you mean? Let me see if I can find another one here. I'll have to make up some stuff here. All right, an aircraft travels 400 miles in 2.5 hours. So at that rate, how far could it fly in 6 hours? Okay, so again, a simple ratio, line equals line. What do I know? I'm looking at miles and hours, miles and hours.
960.
So I've got 400 miles in 2.5 hours. Now be careful, because I'm working in hours, but what if it's thrown out in minutes? Like, oh, if it's 90 minutes, just be careful you keep everything the same. And this is what, 6 hours, and this becomes x. So it's 400 times 6 equals 2.5 times x. So that's 2,400 equals 25x. How do I isolate that x and get it back to just 1x? Divide by what? 2.5. So if I divide both sides by 2.5, what do you get? 960 miles. How hard was that?
Hardest thing I've
So hard, we better do another.
So hard, I had to do another
Hard
one.
enough.
Did they ever
It
have
was
it
hard enough we should have done the
where
election
it's
for that.
like more confusing? Like, do they ever set up problems to try and confuse you
No,
in that instance?
no. They're always going to give you 3 things and you find the 4th. Just set up the ratio. Okay, here's the part, and I'll just jump right into Here's where it gets ugly, or changes. Doesn't get ugly, it changes. That's gears. So gears are the inverse. I want you to, I should take a break before you do gears, but all right. So if I have a gear here with 20 teeth and a gear here with 80 teeth, which one turns the fastest? The 20. This one is faster. This one is slow. Okay, the slow one has more teeth. The fast one has fewer teeth. So the ratio is different, or how you deal with the ratio is different. So let me see here. So if I have a pinion gear, a pinion that has 10 teeth, driving a spur gear with 40 teeth, let me see. And the spur gear is at 160 RPM. What is the RPM of the pinion? Got it? Okay, so I'm going to erase this here. This 60, this 20, and I'm going to write in the right numbers. So I've got 10 teeth, that's this one, driving one of this 40 teeth. And the spur gear has the 40. This one is going how fast? 160 RPM. Okay, 3 things are known. You've got to find one. All right, so it's the same thing almost. Line equals line. Sound familiar so far? I've got a spur gear. I got a pinion gear. But over here I'm going to put pinion here and spur here. I got to flip the other side. If you don't flip the other side, your answer is going to be wrong. So spur gear is how many teeth?
40.
Okay, 40 teeth. I'm going to do teeth. So pinion gear has 10 teeth. And then over here I'm going to put RPM. So I've got pinion is my X, and my spur is going 160. So all you got to do is you got to remember to flop the other side. And so when I look at it that way, then I get 40 times 160 equals 10x, which is 160 times 40 is 6,400 equals 10x. Divide both sides by 10 to isolate that x, and I get 640 RPM. Now, does that make sense? If my big gear is turning at 160 RPM, should this one be faster or slower?
Faster.
And I just said it was 640 RPM. Is that correct? That looks good. What if you forgot to invert? So you did 40 over 10 equals 160 over x. This is failure here. It's why it's in red. That becomes 40x equals 1,600, right? Because 10 times 160, 40x. Divide both sides by 40. So I get x equals 40? 40. So would that make sense then if this one is turning 40?
That makes sense at all, Kevin.
That would not make sense at all. So I guess my point is, number 1, invert it. Number 2, always go back and check your work. It's crazy how many people submit stuff and it's like, do that. So, all right.